Show by the principle of mathematical induction that for all n belonging to the set of natural number, the following inequality holds true. Okay, let us begin. Now in this problem, we do not have to prove the inequality that it is true, but we have to verify that it's a true statement for any natural number n that we pick up. Okay, so let us begin by first considering the statement p of n. So let p of n be the statement such that we have 1 plus 2 plus 3 going all the way up to n. Thus sum is less than 1 over 8 multiplied to 2 times n plus 1 whole squared. Okay, let's call it statement number 1. Now we have to verify that this is a true statement. So how do we do that? It's a very true statement. To do this, we'll first check for n equals to 1. Now for n equals to 1, what we get here is the statement p of 1. Now p of 1 means we'll only have to consider the first term of the inequality on the left hand side. Then 1 must be less than 1 over 8 multiplied to, so 2 times n plus 1 means we have 2 multiplied to 1 added to 1 whole squared. So that gives us 1 is going to be less than, so 2 plus 1, that's 3, 3 squared, that's 9, so we have 9 over 8. We know that 9 over 8 is greater than 1, so that means this is a true statement. This simply tells us that p of 1 is indeed a true statement. Now that we have showed that p of 1 is true, we have to show that it's true for other natural numbers as well. So let's suppose that we consider a natural number m. So let m belong to the set of natural number, and we are considering that the statement p of m is true. We're assuming that it is true. What does it mean when we say that p of m is true? P of m is simply the statement 1 plus 2 plus 3 going all the way up to m. So what we are doing, we are replacing this n with m on both sides of the inequality. So this must be less than 1 over 8 multiplied to 2 times m plus 1 squared. Fine. So we're saying that this is a true statement. We're assuming, and taking the help of statement number 2, we'll have to verify that we'll need to show that the statement p of m plus 1, where m plus 1 is the consecutive natural number to that of m, p of m plus 1 is true. That means we will need to show p of m plus 1 such that we have 1 plus 2 plus 3 going all the way up to m plus 1. We'll have to show that this sum is less than 1 over 8 multiplied to 2 times m plus 1 added to 1 squared. So this is what we have to verify. So how shall we proceed? So here let's call it statement number 3. So in order to verify statement number 3, we'll have to start with statement number 2. We have already considered 2 to be a true statement. So from statement number 2, we have 1 plus 2 plus 3 going all the way up to m. So this sum is less than 1 over 8 multiplied to 2 times m plus 1 whole squared. So this is true. Next, what we'll do, we're going to add m plus 1 to both sides of the inequality. So here m is what? M is a natural number. So here m is being a natural number, so m plus 1, that is also going to be a natural number. Now we know that m plus 1 is simply what? A positive number, because all natural numbers are positive in nature. So adding a positive number to both sides of the inequality is not going to change the inequality symbol here. So that means we're going to now have 1 plus 2 plus 3 going all the way up to m, plus we have m plus 1. So this is going to be less than 1 over 8 multiplied to 2 times m plus 1 whole squared added to m plus 1. Fine. Now we'll have to manipulate the sum of the two terms on the right hand side. So this is going to be, we have 1 over 8. Let's take 1 over 8 as a common factor from each of the two terms. So we have 1 over 8 that will get multiplied to 2 times m plus 1 whole squared added to 8 multiplied to m plus 1. Fine. Okay, so this is going to be 1 over 8. So when we expand to m plus 1 whole squared, we're going to get 4 times m squared added to 4 times m added to 1. Plus, we have 8 times m plus 1, so that gives us 8 times m added to 8. Right. So this is going to be 1 over 8 multiplied to 4 times m squared added to, so 4m plus 8m, so that's going to be 12m added to 8 plus 1, so that's going to be 9. So this is going to be 1 over 8 multiplied to, so this is simply 2m plus 3 whole squared. So when we expand 2m plus 3 whole squared, we're going to get 4m squared plus 12m plus 9. Now, we can rewrite 2m plus 3 whole square as we have 1 over 8 multiplied to 2 times m plus 1 plus 1 whole square. So here what we did, we started out by considering the left hand side is 1 plus 2 plus 3 going all the way up to m plus 1, and we showed that the sum is less than 1 over 8 multiplied to 2 times m plus 1 whole square. This is exactly what we needed to show, and we are successful in showing that. So this means that this simply tells us that the statement p of m plus 1, this is a true statement. This is true. So what have we done here? So we considered the statement p of m is true. We considered that p of m is true, and we were able to show this implies that p of m plus 1 is also true. Now we can generalize it, and we can finally say, hence the original statement p of n, so this is going to be a true statement for all values of n, belonging to the set of natural numbers. That means by using the principle of mathematical induction, we have been successful in showing that this inequality is going to be always true for any natural number n that we pick up.